we're going to start off with the third question here, and this is a no calculator question. And let's just take a look at the setup here. If you look at the graph from 0 to 4, the upper boundary of region R is f of x, and from 4 to 6, the upper boundary is g of x, and it looks like a line. So we're going to find the area of region R here, and because those boundaries change at x equals 4, I have to do two separate integrals because my height of my rectangle is going to be represented by two different functions here. So I'll do an integral from 0 to 4 for that part, and then 1 from 4 to 6, where g of x becomes the upper boundary. All right? So I'll draw a little slice in each one, and that's going to represent my rectangle. So on the left side, right, the height will be f of x minus 0, or f of x. For the right region, the height will be g of x minus 0, or g of x, and I can go ahead and write my area integrals here. So I'll have 0 to 4 of f of x dx, plus the integral from 4 to 6 of g of x dx. Now, the issue here is that I'm not allowed to use a calculator, but the functions are fairly easy to antidifferentiate. Radical x is x to the 1/2 power, and 6 minus x, not too tough, right? So I'll create a little bit more space here in a moment, but when I antidifferentiate those things, I wind up with this, right? And then, of course, I have to follow the fundamental theorem of calculus, antiderivative at the upper limit minus antiderivative at the lower limit. So when I do all of that, and you could work that out on your own, you're going to wind up with 22 over 3. Now, it's significant to mention here that that second region on the right, from 4 to 6, that's really a triangle too. So you could have bypassed the second integral and just used geometry formulas and found the area of that triangle. 1/2 base, which was 2, times your height, which is 4, and that would have given you that. And then you would have done the first integral from 0 to 4 of f of x dx, and then added it to that. So that's part A. Part B, again, there's a pattern with these types of questions. Now they switch from area to a volume component, and this time they want cross sections. So they want the cross sections now taken perpendicular to the y-axis. So we're going to draw our slice horizontally across the region. That's going to be the height, the base of the rectangle, and they give us the height. They tell us the height is 2y. So there's our slice perpendicular to the y-axis. To find the length of that, right, well, I'm going to need the x value on the right side, and that comes from g of x. So I take what y is equal to in g of x, and I solve for x. And then I need the x value on the left side over there, and that comes from the f graph. So I solve for x in the f graph. I replace f of x with y and solve for x. So the length is going to be the the x value on the right minus the x value on the left. So it's going to look like that. That's the length of my base. These are rectangles, so area is simply base times height, although I wrote it here as height times base. And then you put it into your integral. Now your limits of integration are your lowest y value, which is 0 on the x-axis. That's the lower boundary of your region, up to the highest y value the region hits, which is at the intersection of f and g, and that's a y value of 2. Right? Now, not allowed a calculator here, although now that I'm thinking about this might actually be a calculator question. Hold on just a second. Nope, this is not a calculator question, so I have to do this myself, although it says write but do not evaluate an integral expression that gives the volume of the solid. So that's it. I don't have to go any further than that for part B. All right. On to part C. There's a point P on the graph of f, somewhere on f, where you have a tangent line, and that tangent line is perpendicular to the graph of G. So when you see that perpendicular word, perpendicular means they have negative reciprocal slopes, And if we're talking about slope of a graph or slope of a tangent line, we're talking about derivatives. So let's just start off with the g1, because that's a really easy derivative, and it turns out that there's no x variable in the derivative for g. G prime is equal to -1, so the slope of this tangent line they're talking about to f has to be the negative reciprocal of that, so it must be +1. Now, since it's slope of the tangent line, we need the derivative of f. That gives you the slope of the tangent line, so there it is. You set that equal to 1, and you solve for x. Right? When you do that, you wind up with x is equal to 1/4. Now, they did ask for the coordinates of point P, so I need the y value. So I have to go back in to the rule for f, which is just radical x, and find my corresponding y value, and just write a little sentence saying the coordinates of point P are 1/4, comma, 1/2. All right. Now, we're going to stop the video here because the last two questions are both polar graphs, so we'll keep those together in one video here. And please stay tuned for the next one.